Um, here is a lesson on giving a graph, and we want you to identify who is your parent function and then be able to write the new equation with those transformations. I did create this from Desmos.com. You can play around with this website and enter in different values to create different transformations from your parents. So here's our first example. Our parent function is in the red. So we have some points 0, 0, and then 1, 1, 2, 4, negative 1, 1, negative 2, 4. So you should be able to recognize who your parent here in the red is. Your parent function is your quadratic. So that's your f of x equals x squared. It's a quadratic function. So we want you to identify who your parent is and write that equation. So y equals x squared. It's a quadratic is the name for it. All right, and now we need to figure out what is the transformation or transformations that are happening in this new blue function. So I'm going to focus on the critical point 0, 0 here. Notice that our new critical point is shifted to the right 4 units, and then it's not shifted up at all. We also did not change the shape of this new graph. So it's not stretched, it's not reflected. So the transformation is shifting right 4 units. So who this affects is your horizontal axes or your x-axes. So when I think about my horizontal axis, I always have to think opposite. These happen inside the function, the transformations. So when we say inside, we're looking at a quadratic in here. Something inside of here is happening. Now we think opposite. So since we're moving to the right, you'd want to say, oh yeah, let's add 4 to it. But we're going to actually do the opposite. We're going to subtract 4. So our new function in the blue is y equals the quantity of x minus 4 all squared. All right, here's another example. In the red is our parent again. 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. So our parent is the same as the last example. It is your quadratic. So the equation for that quadratic, if you use y or f of x is fine with me. Y equals x squared. Now we need to figure out what our transformation is. So from our critical point, you'll notice your new critical point, your vertex, is down here at the ordered pair negative 2, negative 5. So it's shifting left 2 and down 5. So left 2 and down 5. So let's talk about the left 2. When it's left 2, this is your horizontal axes or your x-axes. We have to think opposite. So let's take care of that piece first. Y equals x, and now we have to think opposite. So since the minus 2 we think opposite, we're going to add 2 inside the function. All right, the next piece, down 5. This is shifting down 5 on your vertical axes, your y-axes. And that is always, y-axis or your vertical axis is always outside the function, outside this parenthesis. Since it's down 5, it's a minus 5. All right, here's our last example. We want to identify the parent. Your parent here is in the red. The first ordered pair is 0, 0. The next one is 1, 1. And then this is over 2, 2 point something. And we're not too concerned about what that 2 point something is. It is a square root function, so you should be able to identify that, your square root. So it's y equals the square root of x. Now we take our critical point 0, 0 and find our new critical point right here. And that point is negative 4, comma 2. So we're shifting, in this case, left 4 and up 2. So left 4 is horizontal axes. That's your x-axis. And then up 2 is your vertical axis, which is your y. All right, so let's write our new equation. So y equals the square root of x is the original parent. Now let's take care of the left. When it's left 4, that's inside the function. That's going to be underneath the radical, underneath the square root. Now I always say inside is think opposite. So since we're going left 4, you want to say, oh yeah, it's subtract 4, but opposite. Add 4 inside the function, underneath the radical. All right, the next one is up 2. Up 2 is a vertical axis, a y-axis. That was outside. So outside the function is outside the square root. Since it's up 2, we're going to go ahead and add 2 to it. So that's how you can create the equations after you've been given the graphs.